Hey guys, at the beginning of this week, we learned how to graph sine and cosine, and the two curves looked very similar to each other. Today we're going to learn how to graph tangent, and you're going to see that it's very different from the other two graphs. Tangent is the rebel. It's always got to be a little different, and you're going to see exactly what I mean as we start to graph this. So if you look down at the worksheet that you have in front of you, I'm asking you to graph y equals tan of x over the interval from 0 to 2 pi. So this looks very similar to everything else that we've graphed so far. 0 to 2 pi is 0 to 360, it's full circle. So what we're going to do is we're going to set it up just like we normally do. We're going to count 3 boxes, and we're going to put 90 degrees, which is pi over 2. Another 3 boxes, which is 180 or pi. Another 3 boxes, which is 3 pi over 2. And then another 3 boxes, which is 2 pi or 360 degrees. And then we're also going to keep the scale that we've been using, and we're going to skip 2 boxes along the y-axis. So up 2 boxes, put a 1, another 2 boxes, put a 2, then go down below the x-axis, -1 and -2. And then, of course, you should have your axes labeled. Okay, so let me give you some time to catch up. I know that I pre-drew in my axes, and that's something that you're going to have to do right now. So I'll just wait and make sure that you have enough time to do that. Okay, once again, this is the same scale that we've been setting up all week. So nothing is new there. We're going in intervals of 90. We're trying to show the axis values, so 90, 180, 270, 360. And then we're going up on the x and the y-axis, the y-axis. 2 units, and each 2 units is going to be a value. So 1, 2, -1, -2. All right, so we're going to graph this, I think, a little differently from the way that we graphed sine and cosine. We really relied on the unit circle for the other 2 curves. We know that in the unit circle, tangent is a little more difficult to find, so we're going to rely a little bit more heavily on the calculator. So I'm giving you the x values in increments of 30 degrees. Notice that the 90, 180, 270, 360 are all embedded in this table. When x is equal to 0, we plug it into the equation, and that's tan of 0. And when you hit enter, you get 0. Do tan of 30. And let's give it, I don't know, 2 decimal places. We don't have to get crazy. Let's do one more together, tan of 60, and you find that it's 1.73. I'm going to move the calculator over for a bit so that I can fill in the rest of the chart, and I want you to do the same. So as you're working, you'll see that I'm working on the video as well, and when you're done, you can look up and check to make sure that everything's okay. Maybe we should do one more together. Let's do tan of 90, because it comes up as an error. Okay, and we know when we were working in the unit circle, when errors pop up, especially with tangent, which is sine over cosine, it's because there was a 0 in the denominator. That's why it's coming up as an error in the calculator for tan of 90. So you're just going to write UND for undefined every time you get an error in the calculator. All right, so once again, I'm going to keep working, and I want you to do the same. You don't have to stop the video. Just keep letting it play, and I'll let you know when I'm done, and you can check your work against mine, and then we'll move on from there. Okay, so once again, as you're working, I'm just using the calculator off to the side. And if it comes up as an error, oops. If it comes up as an error, I just went back and fixed 240 if you happen to be watching at that exact moment. Okay, so I'm done with my chart now. As you work on yours, just take a look up. Okay, and once again, we get this all straight from the calculator. You could also get it from the unit circle, but like we had said before, tangent is a little bit more complicated. It's sine over cosine, which is your y coordinate over your x coordinate. If we decided to put all those things in the calculator, it would take us a really long time. So let's just use the angles in increments of 30 to help us out. And in a moment, I'm going to start graphing these. But I still want to make absolutely sure that everybody has every value that you see here in the table. Once again, all straight from the calculator. This is not something that's overly complicated. Okay, graphing it is going to be a little interesting. Like I said, this graph is going to be a little different looking from sine and cosine. Tangent always has to be difficult. All right, so I'm going to start graphing this. Let's see what happens. So when x is equal to 0, y is equal to 0. So we're plotting a point right here at the origin, nice and easy. Now don't forget, each one of these boxes moving across is 30 degrees. So when x is equal to 30, we're moving one box over, and we're moving 0.58 units up. One box up is 0.5, so we're going just a little bit beyond that. Okay, make sure that you're looking up and you're checking out the points, that they're properly plotted on your graph. Another box to the right is 60 degrees, and that's 1.73. And then at 90 degrees, pi over 2, we have that undefined value. Now what that means is that your graph is never, ever, ever going to touch 90 degrees. So what I want us to do, and I know that it's rough because you don't have a ruler with you, you know, hopefully at this point I might have warned you about this a little bit, that a ruler might be helpful. But if you don't, just draw a vertical line as best as you can. Make it a dotted line. Because what this line represents is a point in your graph that we get really close to 90, but we don't actually touch it. If I was there, I would ask you, what's the name of a line that's approached but never actually touched? And I'd remind you that it sounds like something inappropriate. And most likely a bunch of you would raise your hands and you would say that it's an asymptote. Okay? So what's happening here is these points are being connected and we're getting really, really close to that asymptote without actually touching it. And then we're moving on. So now we are at x equals 90. We're going to move beyond it to x equals 120. And now we're going down 1.73 units. Okay. 150 is another box to the right, and we're going down negative 0.58. So just about negative 0.5, but a little lower than that. 180 is nice and easy. That's 0. And now look what happens. We start heading into the positive values. So 210 is 0.58. 240 is 1.73. And then we have another undefined value. So I'm going to take my ruler. Once again, I apologize if you don't have a straight edge. You know, you could always take out your school ID. You know, every one of you has that on you. And create that asymptote. And then make sure when you draw that curve, you get really close to it without actually touching it. And make sure it looks like a curve. I know I'm not the best artist in the world, and I'm trying to make that look as curvy as possible, and I'm not doing a great job at it. But try your best to make sure that that does not look like a straight line. Mine kind of does. I apologize. And then continue on. So this is 270. When we move one box beyond it, it's 300. So that's negative 1.73. Another box to the right is 330, and that's negative 0.58. And then 360, whew, nice and easy, it's 0. Make it look curvy. And that's what your tan graph looks like. Okay, so very funky, very different from your sine and your cosine curves. Tangent is really easy to spot. If you get a multiple choice question on your Regents exam and you have something that looks like this and you have a bunch of sines and cosines in your choices, you're basically going to know that those are out. Okay, sine and cosine don't have the discontinuity at the asymptotes the way tangent does. So that's what makes this one interesting. Okay. And just like I've done in the past, I want to point out what's happening in the different quadrants. Okay, and I want to compare it to All Students Take Calculus. The quadrants where tangent is positive are quadrants 1 and 3. And if you look at this graph as quadrants 1, 2, 3, and 4, you will see in quadrant 1, tangent is positive. In quadrant 2, tangent is negative. In quadrant 3, we're above the x-axis again, so tan is positive. And in quadrant 4, we're below the x-axis, so tan is negative. So this makes sense. All students take calculus. All right, so I'm going to slide this up just a bit so we can answer the questions down here at the bottom. I'm going to have to move the camera a bit, so just excuse me for a second. My amazing high-tech video here. Paper under a camera. Answer the following questions about the tangent curve drawn above. So the first question is, where is y equals tan of x discontinuous? That's where you have asymptotes. So you might want to write yourself a little note over here that you're looking for the asymptotes. That's happening at pi over 2. Again at 3 pi over 2. It would happen again at 5 pi over 2. And if we were to look on the other side of this y-axis and continue to draw, you would see it would happen at negative pi over 2, negative 3 pi over 2, and so on. So basically, it's going to happen whenever there's an odd number next to pi that's either negative or positive. So in general, you can write plus or minus an odd number pi over 2. Okay, so take a moment, think about that for a second. See if that makes sense. Every time you have an odd number next to pi, whether it's positive or negative, and then you divide the whole thing by 2, you're going to have an asymptote. It's going to be discontinuous. And what I mean by discontinuous is if you were to trace your graph from left to right, you would be forced to pick up your pen. So let me show you. You would be forced to pick up your pen here and move it so that you can continue with your curve. Every time you pick up your pen and you move it to a new spot on your graph so that you can continue from left to right, there's a discontinuity. That's a huge concept in calculus and even pre-calculus. I know all of you can't wait to take pre-calculus and calculus. All right, so now the period is the length of the x interval it takes to complete one entire tangent curve. So in this case, a tangent curve is this wave that goes from below your x-axis to above your x-axis. This is happening from pi over 2 to 3 pi over 2. So if we want to find the difference between them and we subtract them, we have a common denominator. And 3 pi minus pi is 2 pi, and if we reduce that, we get pi. So the period for this graph is pi. This is not like sine and cosine. You cannot find the period of a tan curve by a formula. So you're going to have to look at the graph, and you're going to have to see where your waves are, where it begins, where it ends, and then subtract them to find the difference. So that's the period of the graph. Okay. Domain in this case is actually given to us. It was given to us when we were originally given the setup for this problem. So domain is 0 to 2 pi, but you have to take out the asymptotes. So excluding x equals pi over 2 and x equals 3 pi over 2, because that's where you have your asymptotes or your discontinuity. Okay, now I want you to think about this for a second before I tell you what the answer is. But what's the range for this graph? What are the y values that are being touched? Think about it for a second, and then I'll tell you what my answer is. Okay, so if you look at the graph and you go from the lowest point that we've drawn to the highest point that we've drawn on any one of these waves, we're going from an arrow to an arrow. So we're going from negative infinity, which is less than y, all the way up to infinity, which is also a less than. Okay? So you have to remember your domain and range. We've talked about that a few times, though, this week. And you have to remember if it's a less than or equal to. That's really important. And this is the graph of tangent. Okay, so hopefully you found this to be easy. And the beauty of me teaching this on video is that you can watch it again. I just want to remind you that my YouTube username is lfriedman1230. Some of you know that's my birthday. Okay, so if you, I'm sorry, you can barely see that. If you look that up, you'll see the videos for area of a triangle that we did in the last chapter. And you'll see this video for tangent. Okay, so at this point, you've seen sine, cosine, and tangent. You've even seen sine and cosine with different amplitudes, periods, and frequencies. You're going to receive a worksheet right now, and it's probably one of my favorite worksheets of the year. You're looking at a graph, and you're trying to figure out what the equation is. I think I'm going to go and do a video for that as well, but I want you to try that on your own, and then watch the video when you're done to check your work. And if I decide that that's something that I want you to do with the sub will know, and they'll play the next video. All right, I hope you enjoyed this video on the tangent graph.